All right. This is the third question. This is actually the third question. And the three equations of motions are still here. The first one, the second one, the third one. You understand? The question says two particles, X and Y, starts from rest and cover the same distance. Both of them cover the same distance. So what does it mean? Distance is constant between two of them. The acceleration of X is 1/9 that of Y. The ratio of the time taken by X to that of Y is what? 2. They're asking us the ratio of the time taken of X to that of Y. That's the time taken by X and the time taken by Y. You understand? So we are going to analyze this question. We are going to analyze this question. They said a particle distance is there, acceleration is there, time is there. And now look at these three equations. Which one has distance? Which one has acceleration? And which one has time? This one has acceleration, it has time, but no distance. This one has distance, time, acceleration. This one has distance, acceleration, but no time. So we are going with the third equation of second equation of motion. Sorry, second equation of motion. So that's what we are going with. So solution. L- let's analyze. Let's bring down the parameters first. They say both of them cover equal distance. So distance is the same. So we will not touch the distance. They said acceleration of X. We'll put it AX. AX. That's to show acceleration of X is equals to. They said the acceleration of X is 1/9. 1/9. That's 1/9 of that of Y, of the acceleration of Y. Acceleration of Y. So it means 1/9. Sorry. So it means that acceleration is equals to. So now they now say, what is the ratio of the time taken by X to that of Y? So unknown, Ty unknown too. You understand? We're looking for the time taken by X and time taken by Y. So we, we shall start solving. This is it. Okay. So we are going to use X equals to UT plus half AT square. Now, one thing you should know is that the it starts from rest. Velocity, these two particles starts from rest. So initial velocity is what? 0. Initial velocity is what? 0. So here is 0. So we'll rule it out. So we now have S equals to half AT square. So X is constant since both of them are constant. So we have half 8 AT square equals to half AT square. So this one is going to be for X, X, and this one is going to be for Y, Y. Do you understand? This is acceleration of X, time taken by X. Acceleration of particle Y, time taken by particle Y. So we have two equal things here. We rule them out. Let both of them go. You understand? What is the acceleration of X? AX. What's the acceleration? Y. That's what's it called? AY. This is the appropriate way to write it. Over 9 T square equals to still here AY t square ty square. What do we do? You cross multiply. So we now have 9ay ty square equals to ay tx square. This is tx here. According to the question, they said time taken by ratio of x to that of y. You understand? So we have to put these two into what ratio. You understand? So we divide both sides by ty square. So we divide both sides by ay ty square. ay ty square ay ty square. Now look at what will happen. This out, have limited space. So now look what is remaining here. Now we now have 9/1 equals to tx square over ty square. We can put this in another way, like open brackets. Don't get confused. See, if this is raised to power, if this is multiplied by this, it's going to be tx raised to power 2. So don't be confused. If this is going to be ty raised to power 2. So what do we now do? We square the square root of both sides. This, so this cancel this. So we now have, let me bring this to the other. We now have 9/1 equals to tx over ty. We now have square root of 9 is what? 3/1 tx over ty. So this is the ratio. So which is what? Option D. Option D is correct. Option D is actually correct. So the answer is 3/1. So the time taken by x is what? 3. The time taken by y is what? 1.